Hello dear students, let's start a new topic, extraction of metals. It is the application of electrolysis. Now this topic from chapter 6 of class 10th in subject chemistry. Let's open your chemistry book and come on the page number 125. Extraction of metals, it is also called electrometallurgy. Now what is the electrometallurgy or extraction of metals? It is the process in which electrolysis is used for the extraction of reactive metals which are higher in the electrochemical series, such as sodium, potassium, calcium, aluminum, magnesium. So by the electrolysis process we can extract the more reactive metals, those metals which placed in the higher position in the electrochemical series, such as sodium, potassium, calcium, aluminum, magnesium. These all metals are the highly reactive metals. So extraction of these metals from their ores by using the electrolysis process is called the electrometallurgy, because these metals are more reactive and they have the strong affinity for the oxygens and they forms their respective oxides, and their respective oxides are highly stable. So it is very difficult to or impossible to reduce their respective oxide by conventional reducing agents such as carbon, hydrogen, carbon monoxide, etc. from their respective oxides and extract through the metals. It is very difficult or impossible. So overcome these difficulties by electrometallurgy. Electrometallurgy is which provides a convenient method to extraction of the metals, reactive metals from their respective oxide ores. So here some examples of metallurgy. Number 1, the extraction of sodium. Sodium is extracted by the electrolysis process of few sodium chloride which containing the calcium chloride. Now calcium chloride is present along with the sodium chloride. Then the calcium chlorides which lower the fusion temperature of sodium chloride. So we get the sodium from the sodium chloride, but the calciums added in the sodium chloride because the calcium chlorides lower the fusion temperature of the sodium chloride. Now we can use a electrolytic cell, and that electrolytic cells consist of the cathodes and anodes. The cathode is made up of iron while the anode is made of graphite. On passing the electricity through the electrolytic solution of the sodium chloride, then the sodium chlorides get dissociated into their respective ions, sodium plus and chloride ions, sodium ions and chloride ions, and sodium migrates towards the cathode and chloride migrates towards the anodes, and the following reactions taken place at their respective electrodes. So the reactions at cathodes, sodium migrates towards the cathodes and sodium gain one electron from the cathode electrode and get neutralized and forms sodium atoms, and that sodium atom get deposited at the cathodes which is made up of iron. So the sodium deposited on the surface of the iron cathode. Now reaction at the anode. The chlorine ions, chloride ions, which migrate towards the anode and they lost their one electron to the anode, and it forms the chlorine particles, chlorine atom. That chlorine atoms again combines to form the chlorine gas, and chlorine gas which release at the anode. So through this method we can obtain the 99.8% of pure sodium metal at the cathode. Now next application of the electrometallurgy is extraction of calcium. The calcium is extracted by the electrolysis of melted or fused calcium chloride and using iron as cathode and graphite as anode. When the electricity passes through the electrolyte, that is fused calcium chloride, then the calcium chloride get dissociated into their respective ions, calcium ions and chloride ions. The calcium ion migrate towards the cathode and chloride ion migrate towards the anode, and they get neutralized to their respective electrodes. Now the reactions which happen at the cathode electrode, the calcium migrate towards the cathode and calcium gain 2 electrons, calcium ions gain 2 electrons from the cathode electrode and forms the calcium atom. That calcium atom deposited at the cathode, which is made up of iron. Now the reaction at anode, chloride ions migrate towards the anode, and that chloride ions loses their electrons to the anode and get neutralized, get discharged, and forms the chlorine atom particles. That chlorine particles, a pair of chlorine particles combined to form the chlorine gas. So chlorine gas released at the anode and calcium metal which obtained at the cathode through this process. Now next, third application, extraction of aluminium. Aluminium is extracted by the electrolysis of fused pure alumina Al2O3 dissolved in a fused mixture of cryolite Na3AlF6 and fluorspar CaF2. Now cryolite and fluorspar, this mixture lower down the melting points of the alumina and increase the electrical conductivity. So we can use the electrolyzed fused pure alumina which dissolve in a fused mixture of cryolite and fluorspar, because the cryolite and fluorspars lower down the temperature of alumina and increase their electrical conductivity. Now the electrolysis is carried out in an iron tank which lined with gas carbon. This lining of a gas carbon serve as a cathode, and carbon rod, a number of the carbon rods serve as a anode which is dipped in the fused electrolyte, that's aluminium, alumina, cryolite and fluorspars. Now on passing the electricity, the following reaction taken place in the solutions in the fused electrolytes. The alumina Al2O3, the alumina gets dissociated into their respective ions, aluminium 3 plus oxide ion, aluminium ion and oxide ion. That aluminium ions migrate towards the cathode and oxide ion migrate towards the anodes and get discharged at their respective electrodes. Now the reaction which happen at the cathode is the aluminium ion migrates towards the cathode and they gain the 3 electrons. One atom of the aluminium ions gain 3 electrons from the cathode and get discharged and to form the aluminium metals. That aluminium metals get deposited at the cathode. Now the reaction at the anodes. Oxide ions which migrates toward the anodes and they lost their 2 electrons to the anodes and get discharged and forms the the oxygen atom, and a pair of oxygen atom combines to form the oxygen molecules. So in this process the oxygen liberated at anodes and aluminium get deposited at the cathode. So this is all about the extraction of aluminium by electrolysis process. Okay, thank you.